Welcome to the Minnesota Nano Center. The Nano Center is a state-of-the-art facility for interdisciplinary research in nanoscience and applied nanotechnology.
Minnesota Nano Center is an open-access, state-of-the-art facility for micro and nanoscale research. The mission is to make nanoscale fabrication widely available to the research community. So this could include academic researchers at the University of Minnesota, but also external academic users as well as industrial users.
The Nano Center offers tools to help researchers develop new micro and nanoscale devices, such as advanced transistors, nanophotonic devices, biomedical sensors, and even devices that could be used for quantum computing. The center is also equipped to support research involving nanomaterials and the biological applications of nanotechnology. The facility supports research in nanotechnology by university faculty and graduate students, by external academics, and by researchers from industry and government labs. These projects have led to thousands of publications, numerous patents, and several new startup companies. Much of the work at the Nano Center involves micro and nano fabrication, that is, fabricating devices with extremely small working parts. This is the same process used to make the integrated circuit chips that power all modern electronics. To make devices with such extremely small working parts, we use lithography. This process involves three basic steps: thin film deposition, patterning, and etching. First, a very thin film of the material to be fabricated is deposited onto a substrate, such as a silicon wafer. Next, the wafer is patterned by first depositing a pattern transfer material, called a resist, onto the prepared substrate. Then we apply a pre-designed pattern to the resist. In this example, ultraviolet light is used to optically transfer a pattern from a master known as a mask. Wherever the resist has been exposed to the light, it is changed chemically so that it can be removed in the developer bath. Finally, after developing and removing the exposed resist, the pattern can be etched into the wafer using acids, bases, or energetic ions called plasmas, or by depositing new material into the exposed areas. This process is often repeated multiple times to build up the components that will become a working device. The Nano Center offers a full lithography tool set where patterning can be performed using light or electron beams. We also offer equipment for etching materials using chemicals or energetic plasmas, and equipment for depositing new materials, such as evaporators. In addition to nanofabrication, the Nano Center offers tools for creating and analyzing nanoparticles. Lab users can measure particle properties like size distribution, particle shape, and particle surface charging. The Nano Center supports research into the life science applications of nanotechnology. In our BioNano lab, users can culture and image cells, explore cell nanoparticle interactions, and safely handle microorganisms up to biosafety level 2. A recent addition to the Nano Center's toolset is in the area of two-dimensional or 2D materials. These materials include graphene, a single atomic layer of carbon, and other materials that can be made in single layers 1 atom thick. 2D materials have many promising applications in electronics, optoelectronics, and sensors.
I would like to invite graduate students, prospective faculty, industry members to work with the Minnesota Nano Center.
For more information, please find us on the web and follow the Minnesota Nano Center on LinkedIn.